Hello everyone, we are here again with another episode of prototyping a light duty conveyor belt as part of our video series for automation in construction. In previous episodes, we have designed and 3D printed the drive pulley for our light duty conveyor belt. Our actual conveyor belt has arrived as well, and I thought it's a good opportunity to um, explain something that is called splicing in the realm of conveyor belt maintenance and installation. Splicing refers to um, method of joining two ends of a conveyor belt together to form a continuous loop. So imagine a 28 kilometer of conveyor belt. Obviously, it's not coming all in one piece because it will be a huge burden for the logistics, manufacturer, and all. That's why there are some splicing kits that would combine and join these two ends of the conveyor belt so that it would act as a whole unit. Um, and there are some engineering aspects in splicing and lacing, including the tension that the conveyor belt is carrying out, and also the minimum pulley diameter, because at the end of the day, this whole system has to turn around a pulley or a roller. And if one of these splicing kits um, is so rigid, it's thick, and it so basically what we want to make sure that is there wouldn't be any hiccups when the conveyor goes around the pulley. So these are some considerations that you might have to take into account. For light duty and heavy duty conveyor belts, the splicing methods are relatively different. And we've had a little bit of comparison between light duty and heavy duty conveyor belts in this slide. On the left, we can see that light duty conveyors often use mechanical splicing due to ease of installation and maintenance. Later on, we will discuss what sort of splicing methods are available. And additive splicing or cold bonding is also common for quick repairs. The splicing methods are generally simpler and faster to perform because it's light duty, doesn't need any heavy equipment or manual handling, well, that would be time consuming. And one thing that is really important in splicing is the downtime. Because imagine that a plant or a silo is facing a conveyor belt failure. It normally leads to a total shutdown of the plant. And what is important for the maintenance manager is to fix that issue as soon as possible. And as for the typical splicing methods that are currently available, these methods are constantly being developed by the splicing companies, and just innovation arrives every year, every 5 years, and it becomes easier for the maintenance manager to get their plant back on running whenever a failure happens. We have mechanical fasteners. These are normally like they call clip and lock or MS fasteners or SL self lock. These are some typical commercial names you can find. Basically, there are jaws. One jaw goes in one end, the other jaw goes in another end. Some of them would use a hammering tool to close that jaw, and there's a cable pin passing through these two joints to hold the two ends of the conveyor together. We have rubber-based flexible splices as well, which are getting more popularity in the market at the moment because they can carry out higher tension loads compared to mechanical fasteners. And we have bolt plates as well. These bolt plates are been around for many years, and they have their place in the market. People use them for the longitudinal tiers and both like the tiers that are across along the width of the conveyor. It's not highly recommended to use it for longitudinal tiers, but since it's been around and everybody knows that, knows these bolt plates, they still use it. But there are much better methods, such as using the flexible splicers in for longitudinal tiers. So that was a bit of splicing. And in our light duty example, I'm going to show you what method has been used to bring the two ends of our conveyor, light duty conveyor, together. Okay, so in our light duty example, the splicing method is happen to be a hot splice. As you may be able to see, you can still see the heat press marks on the belt. So what they do, for the splicing, they cut the two ends like finger cuts. They bring them together, and then it goes in a heat press that would, um, with a little bit of chemical adhesives in between, and the heat would basically melt the two ends of conveyor together. And you may want to ask yourself that what constitute the light duty conveyor and what constitute the heavy duty conveyor. It's all about the thickness normally, because rubber is rubber. The only thing that increases or decreases its strength is the thickness. Right now we're having a 2 mil conveyor. It's being categorized as a light duty. Normally anything up to 5 or 4 millimeter will be considered as a light duty. Anything beyond that will be a heavy duty conveyor belt. And obviously the splicing method is going to vary as well. All right, so that was a little bit of splicing. Good to know what sort of belts you're dealing with, because that would determine the splicing method.